So for the second example, it's not enough information. The next one, yes. Diagonals bisect. And then the last one, no. We know that these two are parallel because of the dual perpendicular theorem, but that's not enough because these two aren't congruent. So not enough info. Okay, the last two things that we're going to do for notes today are to look at two types of proofs involving parallelograms. You need to pay attention to these parts because most of your homework for this unit is going to be based on proofs. So, given triangle GBO is congruent to triangle EBR, prove GREO is a parallelogram. And here is our image. Oh my goodness, it's a parallelogram going the other way. Okay, so we have our diagonals. I can do straight lines freehand. If you can't, use your straight edge. GREO, and B is in the middle. Okay, so we know that triangle GBO, which is this one, is congruent to triangle EBR, which is that one. So that's going to tell us things like angle G in this triangle is congruent to angle E in this one, in this triangle. That's helpful because that can tell us that these sides are parallel because those are alternate interior angles. We also know that, well, we also know that this side, that GO, is congruent to RE because those are corresponding parts. So we're going to use corresponding parts of congruent triangles to help us prove that these two are parallelogram, that this is a parallelogram. Okay, so reasons. I am giving myself lots of room for my statements and less room for my reasons because we abbreviate those a lot. Okay, one, given. Triangle GBO is congruent to triangle EBR, and I also have my figure. Okay. We want to say that angle OGB is congruent to angle BER. Notice I have to use 3 letters, and that's because there's multiple angles in those at those vertices. And we're also going to go ahead and say that GO is congruent to ER because it's the same reason. CP, CTC. Congruent parts of congruent triangles are congruent. Now that I've said that, I can say that GO, or I can say that those angles, angle OGB and angle BER, are alternate interior angles. That's the definition of an alternate interior angle. Next, I'm gonna have to slide my figure up. I can say that those are congruent. No, I've already said they're congruent. What I'm gonna do is say that those lines are parallel. GO is parallel to RE, and that is alternate interior angle theorem converse. Now that I've said that those are parallel and I've said that these are congruent, I need to say that GREO is a quadrilateral. That is very obvious from the figure, and that's just going to be definition of quadrilateral. And then last, we're going to say that GREO is a parallelogram. And that's definition. Is it definition of parallelogram? No, it's not, because definition is both pairs of opposite sides are congruent. We're going to say if one pair of opposite sides is congruent and parallel, then the quadrilateral is a parallelogram. All these times that we do the names for our theorems, that's just abbreviation for an if-then statement. We don't have a name for this theorem, so we have to write out the whole if-then statement. Okay, so there's a 2-column proof. Now we're going to do a coordinate proof, and then we will be finished with our notes for today. So, given a quadrilateral has vertices W is 3, 6, E is 8, 6, H is 2, 3, and R is 7, 3. Okay, what we want to do, that's our given, we're going to prove that quadrilateral WEHR is a parallelogram. And we're going to use a coordinate proof to do this. So I'm quickly going to sketch this. Notice all the numbers are positive, so I can just do a positive axis. This is my Y, and this is my X. So we have 1, 2, 3, 1, 2, 3, 4, 5, 6. There's a point W. 4, 5, 6, 7, 8, and then at 6, there's my E. Then we have 2, 3, and that is H. And then we have 7, 3, and that is R. Well, it certainly looks like a parallelogram. How can we prove this is a parallelogram? Well, there are 2 different ways, or a number of ways. We could use opposite sides and show that they're parallel. Since we did diagonals bisecting last time, we're going to do showing the opposite sides are parallel this time. So we need our points. Be sure to reference your points as we figure this out. So how do we show that 2 sides are parallel in a coordinate proof? We show that they're parallel by showing that the slopes are the same. So if WH and RE have the same slopes, and WE and HR have the same slopes, then WEHR is a parallelogram. So let's find the slopes of all of these. Okay, the slope, remember M stands for slope, of WH equals Y2 minus Y1 over X2 minus X1. So that's going to be I'm actually going to start with W and then go to H. It doesn't matter which direction, which one you do first in terms of your points, as long as you keep it consistent. So I'm going to say 6 minus 3 divided by 3 minus 2. That gives me 3 over 1. Next, I'm going to do the slope of RE. RE is 3 minus 6 divided by 7 minus 8. That'll give me negative 3 over negative 1, which is the same thing as 3, which is the same thing as that. Next, I say that the slope of WE is going to be 6 minus 6 divided by 3 minus 8, so that's 0. And then the slope of HR is 3 minus 3 divided by 2 minus 7, which is also 0. So, since the slope of WH equals the slope of RE, and the slope of WE equals the slope of HR, WEHR is a parallelogram. And that is the end of the notes for today.